Today we're going to look at the zombie attack problem. So here's the background. 3 strains of a zombie virus have been discovered in the United States. Each strain is described as below. Strain A. Each day the original zombie infects 3 new people, but the new zombies cannot infect anyone. Strain B. Let's change this. Each day the zombie learns how to run faster so they can infect an additional 2 people per day. New zombies cannot infect anyone. In strain C, each zombie infects 1 new person, and new zombies are able to infect new people the next day. So make a prediction. After 10 days, which strain will create more zombies? Can you explain your thinking? All right, zombie attack. Let's begin the simulation. If you get infected with the zombie virus, you must report to quarantine the front of the classroom on the day you were infected so we can track the virus. And we're going to tally up how many people. I should have cleared this first, which I did not. We're going to tally up how many people are infected after 10 days. So we'll do this simulation in class, and then we're going to use the tallies to complete the tables below. All right, so strain A, and just to remind you, strain A, there's 1 zombie. He infects 3 new people a day. Okay, so on day 0, there's the 1 zombie, and he's going to infect 3 people on day 1. So total, this will be total number of zombies here. This will be number of total zombies. Okay, so 1 zombie on day 1, he infects 3 new people, so there's going to be 4. And then he infects 3 new people, so there'll be 7. He infects 3 new people on day 3, so 10. And each day it's 3 new people. Okay, so by day 7, after 1 week, there's 22 zombies, according to strain A. All right, let's take a look at strain B. Strain B, he infects 3 people the first day, 5 the second day, 7, and so on. It increases 2 additional people per day. All right, so again, we start with 1 zombie. He infects 3 the first day, so this is plus 3, and it increases, so now it's plus 5, so this is 9, then plus 7, so that's 16, then we have plus 9, so that's 25, plus 11, that's 36, plus 13, that's 49, plus 15, that's 64. All right, so by day 7, there's 64 zombies. Each day he infects an additional 2 extra people than the day before. And then strain C, each zombie infects 1 new person, and the new zombies can also infect a new person each day. So on day 1, there's 1 zombie, and he infects 1 person. Then those 2 people each infect a person, and those 4 people each infect a person, and those 8 people each infect a person, and so on. All right, so it says by the 10th day, who has infected more? And we've just done a week, and you can see that strain C after a week is double strain B and much more than strain A. So strain C is the most infectious zombie strain. Okay, using the data, can you sketch the graph of each of the zombie virus? Okay, so here we have 0, 1, 1, 4, 2, 7, 3, 10, 2, 7, 3, 10, 4, 13, 5, 16, 6, 19, and 7, 22. All right, so there's strand A. Let's take a look at strand B. We have 0, 1. We have 1, 4, and look, this is scaled differently, so 1, 4 is like here. 2, 9. 3, 16. 4, 425, 536, 649, 764. Okay, and then last we have strain C, 0, 1, 1, 2, 2, 4, 3, 8, 4, 16, 532, 6, 64, 7, 128. Looks like somewhere up here. All right, so we have these. Let's look at the types of functions. The first one's a straight line, so we'd call the first one linear. The second type of function is half of a parabola. And we've looked at parabolas before, so you can see it's half of a parabola here, so it's a quadratic. And then this new type is our exponential, which we looked at 2 days ago. Write that better here. Exponential. All right, let's write the equation of strain A. It's linear, so we need a slope and a y-intercept. So the y-intercept at day 0, start with 1, and the slope is 3. We're adding 3 zombies per day. So if you write that equation, that would be y equals 1 plus 3x, where x is the number of days. The quadratic function right here, if you notice, all of these are square numbers right here, but they're like 1 less than the number that we need. So for example, if you take 2 squared, you'll get 4. If you take 1 squared, you'll get 1. 3 squared is 9. So what we need to do to account for that is we'll say y equals, and it will be the day plus 1, and then square it. So again, if we take the day plus 1 and square it, we will get the number of zombies. So for example, 1 plus 1 squared is 4, 2 plus 1 squared is 3, 3 squared is 9, 3 plus 1 squared is 4, 4 squared is 16, and so on. So there's our equation. And then for strain C, it's exponential. So we need a starting value and the growth factor. So the starting value is 1, and it's doubling every day. So we have y equals 1 times 2 to the x. And we've been using parentheses, so stick that in parentheses as well. Okay. What if a zombie entered the new U.S. Bank Stadium? The capacity of the stadium is 73,000 people. How many days will it take for the whole U.S. Bank Stadium to be infected if A walks into the stadium, B, or C? So we're going to make an equation, and we have the capacity, which is 73,000. We're going to set that equal to 1 plus 3x. All right, so this you will solve algebraically. You'll subtract 1 divided by 3. That one you should be able to do. The next one is 73,000 equals x plus 1 squared, and we're going to solve that. So to get rid of a squared, how do you do it? You're going to square root. So if I take the square root of 73,000, it's about 270.18, around a 19, and that equals x plus 1, and you'll subtract 1 from each side, so x will be about 269.19. Alright, so it'll take this long, and if we solve this one, I guess we should solve it, we'll subtract 1 from each side. We'll get 72,999 equals 3x, divide by 3. And we get 24,333. So this will take 24,333 days. This one only takes about 270 days. And then strain C, we have 73,000 equals 1 times 2 to the x. Oops. And this is a guess and check problem, so you have to figure out plug in for x so that when you hit enter, how many days will it take you to get 73,000? So I'll let you do that for your assignment. And then number 2, same thing. If a zombie outbreak occurred at SLP High with a student population of about 1,400 students, how long would it take to infect all the students? Show your work for all 3 strains. All right, so I'll set up the equations for you. So strain A, 1,400 equals 1 plus 3x, and you would solve. Strain B, 1,400 would equal x plus 1 squared, and you would solve. And then strain C will be your guess and check, and that would be 1,400 equals 2 to the x. Oops, and you would solve. So for your assignment, you'll plug in and solve into your linear, your quadratic, and your exponential, and see which one, how long it would take to infect the students with each of those strains.